Welcome in fifth practical of practical second. This is for the first year student of second sem of IIHS. Here we will find exact solution of first and second order ordinary differential equation using inbuilt function of maxima I22, OD2 and IC1, IC2. So first I will tell how to enter the differential equation in Maxima software. Then I will solve first order differential equations and I will take initial value problem. I will first solve the differential equation manually and then I will show how the answer you will see in the Maxima software. I have taken this differential equation. My differential equation is x cube dy by dx plus 3xy equal to sin x by x, and the initial condition here given, value of the y, it is 0 when x is equal to y. As you know, this is differential equation ordinary, dy by dx is here. So y differentiating with respect to x. So x is your independent variable and y depend upon the x. So first you will enter this differential equation in Maxima software, and I told you the syntax for this is dy by dx is written by this symbol dash dy by di double f y comma x. So I am copying this one and taking this in the Maxima software. I already wrote this syntax here, x power 2 star dash di double f y comma of x. This is symbol. When you run this, shift enter, you will see this differential equation is entered in the memory, and this is I wrote here input 1 and it is my output. Okay. Then I am solving this differential equation first. So it's this is a type of equation type second, and it is a particular Leibniz equation. So first you will take the coefficient 1 which is already given here. So I find the first p. On comparing this equation first with this equation second, my value of p is 3 by x. So this type of equation is solved by integrating factor. So integrating factor, the formula is e exponential integration p of x d of x. Write here 3 by x, take this 3 outside, and integration of 1 by x which gives you log of x. I already solved this. This is integrating factor in green words. So integrating factor, on solving this 3, I can take here x ki power 3 and e and log cancel out. So integrating factor for equation first is given by x cube, and solution of equation second is given by this formula. This is y into integrating factor is equal to integration q of x. Now you will write integrating factor here and d of x. In my question, this sin x by x cube is your q of x. So put qx and integrating factor here in this expression. Okay, so it is, the solution of my equation first now becomes it is y into my integrating factor. I calculated this is x cube is equal to q. The value of q is here sin x by x cube, and into integrating factor which is x cube d of x. Now cancel this x cube with this x cube. Here is sin of x, and integration of sin x is given by minus of cos x. So equation 3 is the solution of equation first. Now here is a constant. We will check this in my software. You can also check this one, y into x cube. You can write this is y is equal to c minus cos x by x cube. Now I will calculate first this solution c using the initial conditions, and initial condition is y at pi. You can see it here. Y at pi is given here 0. Remember, here the value of the dependent variable at when x is 0, pi is given to you 0. So put x is equal to pi in my solution equation, which is 3. So it becomes y at pi, it is pi cube, is equal to minus cos pi plus c. As cos pi is minus 1, so it is plus 1, and this is 0, so c comes out to be minus 1. Now put this minus 1 value again in equation 3. I obtain the particular solution for this equation is y x cube is equal to minus cos x minus of 1. You can take this minus outside. You can write this like this also. You can take minus outside. So it is plus, it becomes plus here, and your solution is given by equation number 5 now. Now I will verify this solution in your MAXIMA software. As I told, we have to use OD2 functions, inbuilt function in MAXIMA software. So how to do this? First you will enter the given differential equation, which I already told you the syntax. देखिए x power 2, so you will write x. This is on the key 6. Shift and press 6 key, then you will obtain the x here. Okay, here you will write the star, and star is on key 8. So shift and 8 press करेंगे, you will obtain the star. So enter this. I already entered this. I have shown in input 1. Now what is the syntax for find the solution of this differential equation? OD2, this function is available in the MAXIMA software, and it will solve a differential equation of order first and order second. Syntax for this is you will write OD2. In first position you will write the differential equation which you want to solve. Then you will write DVAR, it means dependent variable. In my question, my differential equation is, I will write here this label. Otherwise you can write percentage sign, it means just immediate before this line. Okay, so dependent variable is y and independent variable here is your x. So your syntax is, you will use here OD2 percent, it means it will call this percent output 1. Shift and enter. It's my solutions. This is y is equal to percent %c. In MAXIMA you will write, you can't write C1. Here you will obtain percent %c. It's the symbol for writing the constant and cos of x by x cube, which I already obtained in my solutions. Now I want to find this constant value using the initial conditions. Here the differential equation is order 1, so you will use the inbuilt function IC1. So what is the syntax for this? Function's name is IC1. Here you will enter solution, यानी कि output 2, and you will mention the x variable, मतलब dependent variable, independent variable, value of independent variable, and y which is your dependent variable. तो उसकी corresponding जो value बनेगी, you will enter this values here. In my question, value of x is pi and corresponding value of y is 0. So I will write here IC1. My output solution is %O2, output 2. You can write just % because before this line output is output 2. Otherwise you can write label of your solutions where you want to find the constant. So value of x is here pi. The syntax for this is %pi, and the corresponding your dependent variable is y is equal to 0. And I already solved this, and the solution here is the constant value I obtained is -1. So shift enter, your output is this one. Minus sign is outside, cos of x plus 1 by x cube, which I already obtained here in my solutions. देखिए हमने solve भी किया था. तो y is equal to what? This x cube you can write downward and minus is outside. So this is the how to find the solution of a ordinary differential equation of order 1 with initial condition is given. So you will use first order differential equations IC1 to find the value of the constant. Now we find the solution of second order ordinary differential equation. So here I have taken the second order differential equation, which is shift enter. देखिए dash diff di double f, dependent variable y, derivative with respect to x, and this is second order. So it is d square y by dx square plus y star dash differential y x power 3, means dy by dx cube is equal to 0. It's my differential equation for second order. You can take any differential equation from your book which have already solved in the class. I will give you the assignment here also. So first I will tell you how to obtain the solution for this. I will solve this in another way. I already take the solution of this one. As this is second order differential equation, there will be two constant. So I am giving you question first to find out the differential equation corresponding to this solution set formulation which you have already solved in your class. To find the second order differential equation solution, I have taken the example. Example is d square y by dx square plus y dy by dx cube is equal to 0. It's my second order differential equations and it is non-linear differential equation. Here y at 0 is given to you 0 and derivative of y at 0 is equal to 2. It is initial value problem, and as the order is 2, so there are two constant in the solution of this differential equation. I already saw I will solve this differential equation with these boundary conditions, and here y at 0 is equal to 1 and y at 1 is equal to 3, and this type of equation are known as boundary value problem. So I will give you the solution of these initial value problem and boundary value problem in MAXIMA software. I already solved this differential equation. Y cube plus 6k1y by 6 is equal to x plus k2. As this is second order differential equation, there will be two constant, one is k1 and one is k2. You can take the differential of this one and eliminate the constant k1 and k2. Again you will obtain this differential equation. You can verify. Okay, जैसे आपने क्लास में किया था तो आपने वेरीफाई किया था corresponding to this curve, its differential equation is question number 2. Okay, अब हम सॉल्व करेंगे इसे इन द मैक्सिमा सॉफ्टवेयर. फर्स्ट ऑफ ऑल आई विल एंटर दिस in the MAXIMA software, and syntax for this one is this differential. I will show it here. Syntax you can write is dash diff y x and 2. This 2 indicate here you want to differentiate y 2 times with respect to x. Y it's star dash. This is the symbol for to write the dy by d of x, and it's the power of this dy by d of x, this format. So first of all you will enter this differential equation in the MAXIMA software. So I already solved this here. So in input 4 I will write this shift enter. This is enter in the differential equation. Now you want to find the solution of this one, and to find the solutions my syntax is OD2. You can write here the label of this differential equation, that is 0 5 output 5 and y d of x. So its solutions y cube plus 6k1y by 6 is equal to x plus the second constant is k2, so percent sign is here. Now to find the solution, to find these constants using the initial conditions, there is an inbuilt function IC2. If you want to find the one constant, that is first order differential equation, you will use IC1, and to find the two constant you will use the inbuilt function IC2. Again the solution above line, and x value, y value and initial value problem है तो derivative of your y at this point. Okay, so my first differential equations, first initial value problem is x1 0. Now the output I obtained is here in the 6th line, so I will write here 6. So rat simplification function, you are already familiar with this, so this will simplify your expression. Percent, this is the label of your solutions, because in this expression I want to find this constant k1 and k2. Here you will write x. Initially my y is 0 at x equal to 0, so I will put x equal to 0 and y is also 0 here. The second initial condition is derivative y at 0 is 2. So the value of x is same, so I will not change it here. Just write here dy by dx, value is assigned here 2. When I assigned it here, you can verify your constant k1 is obtained 3 and your k2 is obtained here 0. You can practice more question from the book. Here I also want to introduce the boundary value problems. So how to find the constant in this? So I am taking the same differential equation second order, which is you are entering in the 5th input line. Here I am changing the boundary condition second. My second boundary conditions is this one, y at 0 is 1 and y at 1 is equal to 3. First you will put all these two conditions in your solution set. This one, first you will write x is equal to 0, y is becomes 1. So you will obtain the two equations in the form of k1 and k2. Manually you will solve first and then verify the answer you obtain in MAXIMA software. Now the how to enter this and how this software obtain these two constants. For this you will write BC2 boundary conditions, because you are using for second order. First order you will use only the C1 IC1. So First you will write BC2. Here you will write the solution. Now the solution is in the equation number 6. In the output 6, this is the solution. You want to find the constant K1 and K2 here. So first you will write this label here, output 6, and you want to write y at 0 is equal to 1. So how to write this one? You will write first independent variable x is equal to 0 and the corresponding y value becomes here 1. If comma, then you will write x equal to 1, y is 3. It means y at 1 is equal to 3. Shift enter. I already run this, that's why you are seeing the output here. Okay, so when you find this, the K1 comes out to be minus 10 and the value of K2 is minus 3 by 2. Verify this, because in examination we will give you a differential equation and you have to solve this manually as well as in your MAXIMA software. Okay, now you can practice more questions. I gave you this differential equation, d square x by dt square plus 4 dx by dt plus 3x is equal to 0. It's homogeneous linear differential equation with constant coefficients. It's your exercise question. I use here initial condition, this one, when t is equal to 0, x is equal to 0 and dx by dt at 1 is equal to 12. I use it here. So how to enter this one? Dash di double f x t, second order है तो you will write 2 here plus 4 dx by dt plus 3x is equal to 0. So first I will enter this one. So it's my becomes input 9 and corresponding differential equation is this one. First I want to find the solutions. Here my dependent variable is x and independent variable is t. So you will use the function. Which function? OD2 percent means just I am calling above line, above output. So you will write only percent here, x and t. Here there will be two constant, that is K1 and K2. Its solution is equal to x is equal to K1 e की power minus t and K2 e की power minus 3t. You can solve this by auxiliary equations and d square plus 4d plus 3 equal to 0 and the roots are minus 1 and minus t, lambda 1 and lambda 2. Okay, now do you want to find these two constant K1 and K2 using the initial value problems. So here initial value problems are, you can write red sim or already you can write IC2 also here. मैंने क्या किया है, just I want to find the constant K1. I am putting here x at 0 is 0 and dx by dt at 1, dx by dt at 1 is equal to 12. This is boundary value, initial value problem है. Just dx by dt at 0 is also here. ये इंडिकेट कर रहा है कि आपने फर्स्ट ऑर्डर डेरिवेटिव लिया. x t की वैल्यू 0 ही है. इट्स इनिशियल वैल्यू कंडीशंस. Again I am saying that this is x at 0 is 0 and dx by dt, it indicates that you are taking first order derivative. And again at t equal to 0, value of this one is 12. When you simplify this one, your constant C1 comes out to be according to this. There is a problem. I obtain a problem here because not a proper differential equation. This is because here I give the label %09 and I run more command here. So percent means it's taking just previous input and previous input is not this differential equation. So I should change the label, then it will work here. So for this 09, my output is at 09 position. So output 09 shift enter gives you the solution of this differential equation, that is k1 e k minus t, k2 e k minus of 3t. Now I want to find this constant k1 and k2. I manually solve these two constants, and you can take this e k minus 3t inside. So this constant k1 is equal to 6 here, and the value of k2 is equal to minus 6. You will verify this one by solving manually. Okay, so this is the how to find the solution of a differential equation of first order and second order in Maxima software using the inbuilt functions IC1, IC2 and ordinary differential boundary value के लिए BC2. So you practice more questions as I gave you in the assignment, and last you will quit and shift enter. So here it shows that Maxima exited and trying to restart Maxima. अगर आपको दोबारा करना है तो you will write the beginning. So it's your program to find the solution of first and second order ordinary differential equation. Practice more questions from your book. Thank you so much for watching.